Hello everyone. Today we shall learn about De Morgan's law in Boolean algebra. Here also we are considering the same Boolean algebra, the fourth tuple b plus dot complementation, where the addition or plus and multiplication or dot are two binary operations and this complementation is the unary operation. And we have considered the same Boolean algebra b plus dot complementation as we have considered in our previous classes. And De Morgan's law in a Boolean algebra indeed tells us, if you consider any two members, here as we have considered a and b, and we have added these two, a plus b, and the addition being a binary operation, obviously a plus b is an element of b being a Boolean algebra, and here we are considering the complement element of a plus b, and this is equal to the complement element of a into the complement element of b. This is the first proposition of De Morgan's law. Okay, this is the De Morgan's law for addition. This is the De Morgan's law for addition. Similarly, the dual of this proposition is a into b whole complement. This is equal to a complement plus b complement. These two propositions are called the De Morgan's law. And obviously, these two being duals of one another. If we can prove any one of them, the second one will also follow. So let us now consider this first one and try to prove it. Here we have considered a plus b plus a complement into b complement, and we have applied the distributive law for addition over multiplication. So this would be equal to a plus b plus a complement. Here we have written that very a plus b plus a complement into a plus b complement. Here we have written that a plus b complement. Okay, the addition binary operation being commutative, in place of a plus b plus a complement we have written a complement plus a plus b. And for this second part, we have used the distributive property of addition. Sorry, we have used the associativity property of addition. So a plus b complement, this is equal to a plus b complement. A plus b complement. We have written this. Okay. Now for this part, a complement plus a plus b, we are again using the associativity property for addition. So this would be equal to a complement plus a complement plus a plus b plus b. And for this second part, we all know that if we add with any member from a Boolean algebra with its complement element, here b plus b complement, this would be equal to the multiplicative identity element 1. So here we have written a plus 1. And similarly, a complement plus a, this would also be equal to 1. So we have written here 1. So this is 1 plus b. This is 1 plus b. And the second one is a plus 1. A plus 1. And in one of our previous classes, we have proved this property that if we add the multiplicative identity element with any other element from Boolean algebra, the resulting element will be 1, the multiplicative identity element. So 1 plus b is equal to 1. Similarly, a plus 1 is also equal to 1. 1 being the multiplicative identity element. So 1 into 1, this is actually equal to 1. We have written here. So what we have obtained? A plus b plus a complement into b complement, this is equal to 1. We have written here that very. A plus b plus a complement into b complement, this is equal to 1.